Hi everyone. So moving on to balancing chemical equations, there's just a few things I want to note before we go into some examples. So I actually wrote out the steps for you here. Before you balance a chemical equation, you want to make sure that you list the starting number of atoms on each side of the arrow. And we know that on the left side of the arrow, they're called the reactants, and on the right side, they're called the products. So make that part of your normal vocabulary. If the number of atoms don't match on both sides of the arrow, you're going to change the coefficient, which is that big number that goes before the chemical formula. You're never going to change the subscripts, so you won't see me do that in any of the examples here. Once you adjust the coefficient, that's going to affect the number of atoms on each side of the arrow, so you then have to adjust those. And then you kind of keep repeating that until everything is balanced. Now this will make a little bit more sense with some examples, so let's move on to that. So here we have a chemical formula where we have the reactants here and the product here, okay? So the way we kind of organized it in class is this. I kind of use the arrow as my separator, and then what I like to do is list out the elements that are present. So here we have carbon and oxygen, and if everything is right, then we should also have carbon and oxygen here. So I'm just going to list carbon, put little hyphens, oxygen with little hyphens, and here's where we're going to do our tallies. So right now, on the left side of the equation, assuming that the blanks are just a 1, right, because there's nothing listed there, we have 1 atom of carbon and 2 of oxygen. And over here, we have 1 of carbon and 1 of oxygen. So this equation is what we say is not balanced. The carbons match, but the oxygens do not. So we know that over here on the right side, this needs to increase, but we can't change anything until we change the coefficient. So instead of the implied 1 here, I'm going to make that a 2. That's going to then impact the number of carbons on this side and the number of oxygens, because the 2 is now a coefficient. So that becomes a 2, and that becomes a 2. Now we have our oxygens matching, but we don't have our carbons balanced. So we now then need to increase the left side. So if I put a coefficient of 2 here, that changes this to a 2. And now everything is balanced. The blank you can just fill in with a 1, because there's only 1, that's what we counted. And with the coefficients you wrote in, your equation is now balanced. So let's go ahead and try the same thing for example 2. So in example 2, we have our sodium, we have chlorine, and we have oxygen. Now again, just writing them beneath the arrow is just our way of organizing the information. If you find another way that works for you, that's totally fine. So again, as we count the atoms, we're going to look on the left side and the right side and assume these coefficients are 1 until we change them. So over here on the left side, we have 1 sodium, 1 chlorine, and 3 oxygen. Here we have 1 sodium, 1 chlorine, and 2 oxygen, right? So we see that everything balances except for the oxygen at this point. So we need to increase the right side because this is only a 2. So I like to just increase them until you get really good at it. Increase by 1 the coefficient. So if this is a 1, I'm going to just make this a 2 and just see what happens. The only thing that changes is that makes this a total of 4 oxygen atoms because of that 2 times 2. But then we see that we have to adjust the right side because the oxygen over here now needs to increase. So let's up this to a 2. But when we put a coefficient in front of this whole formula here, everything is impacted. So instead of 1 sodium, we now have 2. Instead of 1 chlorine, we now have 2. And 2 times 3 gives us 6 atoms of oxygen. Now we're almost there. Obviously, once doing that, now our sodiums and our chlorines are not balanced. So if we make this a 2, we now have 2 sodiums and 2 chlorines. And the only thing that we need to fix is the oxygen. So if we change this to a coefficient of 3, we have that 3 times 2, which gives us 6 oxygen, and now we can see that everything is balanced. We'll do example 3 the same exact way. We'll list out, we have aluminum, and we have oxygen. On the left side here we have 2 and 3, and on the right side here we have 1 and 2, right? So aluminum's not balanced. Let's go and make this a coefficient of 2, which changes this to a 2. We're almost there, except oxygen isn't balanced. If we up this from a 1 to a 2, we end up with a total of 4, which still isn't balanced. So let's head over to the left side, because this needs to increase. And we do that by changing this to a coefficient of 2. Once we do that, it impacts the aluminum and the oxygen over here. So that gives us 4 aluminum and 6 oxygen, which we can actually pretty easily fix and balance by looking to this right side, which is a 2. And I'm going to skip 3 and increase this to a 4, because the coefficient is only for aluminum. It doesn't affect anything else. So if I change the coefficient to a 4, this guy becomes a 4. And now the oxygen over here, we need to make this a 6. We know that 3 times 2 is 6, so that's a coefficient of 3, making that 6. And now we're balanced. Now example 4 is a little bit more challenging for a couple reasons. The first thing that you should notice is that we have parentheses here, so just don't forget your rules about the subscript that's outside of the parentheses. And then the other thing that's a little bit different is that we have oxygen on our product side. We have oxygen in 2 places. We have it here and we have it here. So when we tally everything, we need to make sure that we count all of the oxygens together. So let's go ahead and list them out like we normally would. We have iron, oxygen, and hydrogen. All right, so as is, it looks like we have 1 iron, 3 oxygen, and 3 hydrogen. Because remember that subscript applies to everything inside. And over here we have 2 iron. We have 4 oxygen because we have 3 over here and 1 over here. And then we have our 2 hydrogen over here. All right, so let's start out by looking at these iron atoms. Over here on the reactant side, let's increase this whole coefficient to a 2, but we know that's going to affect everything else. So once we change that to a 2, we now have 2 irons. We now have 6 oxygens and 6 hydrogens. So that means that we're going to have to kind of look at this side again. Irons match at this point, but the hydrogens and the oxygens don't. So let's up this from the implied 1 to a 2. So now hydrogens we have 4, and oxygens we have 2 from over here, but then we still have the 3 from over there, so that's 5. We're almost there, but not totally. It doesn't seem like we have enough oxygen or hydrogen over here on the product side. So if we make this a 3, that means that we're going to have 3 times 2, so 6 hydrogen. Okay, that's good. And then we have 3 oxygen over here, plus our 3 oxygen here, which gives us 6 atoms of oxygen, which is exactly what we want. So we can fill in the 1 here, and everything is balanced. All right, hopefully this is helpful. Let me know if you have any questions.